So in this week we're gonna cover unit bless you. We're gonna cover the third unit, and in this unit we're gonna talk about a little bit more on the web recon side. I think that you're gonna see how these roles for the web servers can be used. I want to take the opportunity to show you how you can configure it in Linux, because most of the servers for the web servers out there are Linux. So we will set up the roles, and then you will attack your own server. So that way, in case you want to build your test environment, you'll be able to do that. So before we dive into, all the scan tools and the recon tools for the different role of the servers, we want to touch a little bit on some of the processes that's happening with the web server, because if you understand it, it's going to help you be able to see the clearer picture when you get the information. So we know that when your client is connected to the web server, it goes through a get process, right? So when I type in the domain name like google.com, it's going to so my traffic goes from my network, leaving my internet service provider across, and then get to the DNS, which is going to resolve the IP for the URL. Then we are trying to get the file that's being served by the server. So basically the web server job is to be able to provide us with data and information that our system is asking for. So now in that, over time in the development area, we have to find a way to track on how the servers respond. And the best way that we can come up with, and we're still using that, is to have a set of codes that would specify the type of response that the server is giving. And in the back, when you are using Recon tool, you're going to see a lot of this coming through, right? So I want to spend a little bit of time talking about this, and I also go over this in my 41A class, because predominantly in the industry, most of the applications are web applications, meaning that it's hosted on a web server somewhere and the data is housed in a database somewhere. So we have to understand the aspect of web servers and other components that goes into the web server. So having this understanding is going to help you troubleshoot in the case that if you become a network admin or a system admin. Also to analyze the code on the development side. So whenever that you might to have access and work with developers, you will be able to have a better understanding. And I borrowed this picture from the internet, and it kind of shows you like the process in how your page is being loaded. So when we're going through the GET request, because HTTP is part of the TCP suite, it needs some form of confirmation before it actually allow, right? So acknowledgement needs to be made for that connection in order for the data to come through as in the content for the packets and be able to be presented through the application to show you on your screen as a client. So you're here, right? You're putting in the domain request information, and then sometime you would come across redirect, where let's say if I want to retire a certain domain, I can redirect it to another domain, and we have to have a set of codes to actually communicate with the system. So that way we would see what the type of response would be. So the best resources for this is you can go directly to Mozilla. So I put some link here for you to kind of show you like all the HTTP responses, because if I was to even copy and paste or type that out, that would be a long while, because there's a huge documentation on this. So if you're not sure, you can always go to the documentation from Mozilla and then you can look it up. Okay, so let's go through and answer some questions. For number one, it asks you, why are web server responses important? It's so from our perspective in networking, IT, and cybersecurity, web server responses contain successful and failure connections. which is helpful in troubleshooting, especially if that's the area that you're overlooking. In development, if you are programming and you're maintaining the codes and the content of the website, networking, which comes back to connectivity, and security improvements. And we'll take a look at the banners today to kind of see how that plays into the security area. Any question? So we're probably not going to move into attack mode until next week. And so what we'll have to do is I want to teach you some of the basic recon stuff before we get into putting together like an attack set of tools. So you can go to the site and you can copy and paste some of the definition they give, or you can type it. So I tried to put some of the things that we can use as security professional or IT people, right? So 102, if you see this, right, on your screen or on the page when you're trying to connect to that site, a lot of times when you're monitoring, you're also seeing some of the code coming through. That means that it's received the request, but it's not responding, or the response is not available yet. So it's possible that that server might having some slow issue. A lot of times if it is responsive, you're gonna see 200 okay. So anytime you see 200 in the server response status code is okay, right? And then you can go down the list on that website. 204, it means that the request is succeeded, but the new source was created as the result, and that's typically because it's sent after the post request or some put request. Now, for the post request, so in the development area, we can take a look at this. This might be something that we need to look at the process issue and how the post request needs to go in. And so we want it for the request to be succeeded. So the response needs to be in a timely manner for the first one. B is okay. 204, this might be something that we have to fix on the web development side or even connectivity side. For 301, URL requested has been changed permanently, like I said before. Sometimes you have company buying out company, or a company, they went bankruptcy and they sold the rest of, all their resources like customer, all of their equipment to another company. So eventually they're going to phase out the .com or whichever the domain would be. So if the URL is changed permanently, a given URL is included in the response. And you want to do that. You want to include the new URL for your customer to go. 305 is defined in the previous version of HTTP specification, indicating requested response must be accessed by a proxy. And sometimes they want you to go through a proxy in order to connect for security reasons. So proxy can be used to be traffic police, right? We know that proxy can be placed in a certain location of the network to pass traffic. It can also act as a way that we can monitor traffic. We can screen the traffic. We can use proxy to load balance some of our traffic. So instead of going down one path or two paths, we can have it multiple paths where these proxy would be able to, check and send, right? So basically that's the middle type of system that will be able to overlook some of the traffic. And so that means that we need to configure a proxy and connect it to a proxy. And sometimes that could be for security reason. Other times could be for performance for the network reasons. 400, we're familiar with 404. I'm pretty sure when you're trying to visit a bad URL or something that's no longer there, you're going to get a 400 code. So the 400 simply that the server cannot and will not process the request due to perceive that the client error. That could be that they're typing the URL wrong. Something is wrong or invalid request, message framing, or routing. So in the technical area, if we're taking a look at 400, a lot of the times it's connectivity issues. Okay. It could also be that, you know, your traffic is not being passed to the greater network to WAN. So you would see that. And on the programming side too, the development side, they also include some of that information to check the status code. Yeah, so you can find all of that in Unit 3 module, the notes.
Gives you the link to our website where you can find out.
So the 401, we know that this is specifies as unauthorized, and you can, whenever you see 401, that's unauthenticated and unauthorized. And it must be authenticated to get the requested response. So in the case where if somebody is trying to click back and then forward again to the same page, they might get that error code, or sometime it will just say that session is ended because, you know, you have a security session for that user once they're authenticated. So once it's ended, they're no longer able to access the content, or someone is trying to access things that are not authorized for them. You would see 401 coming up. 403, basically they don't have access right to content, very similar to 401, but the server is going to refuse the request resource. So 401, all the user needs to do is to authenticate. Perhaps they don't have the credential or they don't have the correct credential. The 403, right? The 403 is that the server will not serve the content. They just not gonna, you know, so even if they're logged in successfully, they might not be authorized. They will not be authorized, right? So 413, it's too large. So this deals with your header and your field or your data. And when you look at your header today, you're gonna see the length of your header. And then also some pieces of the header, it's gonna also show like how much data you have, because we know that as web traffic comes through, your data packets is various. It's not gonna be all in the same size, even though it's intended to use one frame type, but you're gonna have something that's different in all sizes. And then you got UDP and then TCP traffic, right? A lot of times you see the UDP because it just sends, so it's a lot quicker to have throughput, and the UDP size you can also determine. So UDP header is different than TCP header. TCP is very clear about who's sending, right? Because it needs to have acknowledgement. UDP, it does have source and send, but it doesn't have much of a requirement, like it doesn't need a sequence number, because a UDP packet compared to a TCP packet, UDP packet can arrive whenever. So I might have the 11th packet arriving before the 9th packet way in advance. So this is why when you're watching a video and it's still buffering because your packets is still arriving and your system is still trying to put everything together. So I might have the 11th packet already arriving, and then the first packet is maybe delaying a little bit. So that's why you still have that buffer. So a lot of the media-based content needs UDP. So what you would see is that, you know, from the administration side, when you work with, you know, like your entire infrastructure, you got to look at how your web is. Even if someone else is hosting it on the cloud, you want to make sure that it has throughput, and that's part of availability for security as well. So I wanted to touch base on some of the main ones, but if you have time, you can go through that list and take a look. It's interesting. So a web server doesn't need to be a super fancy, powerful computer, right? It can be a computer that is just running web services. That's what we've been doing. And today you're going to see some of that. You can use your Kali Linux. You just have to install and enable the services that it's using, and then turn that on and be able to, you know, put a web page on there and then, you know, add content to it. So whoever is trying to reach it will be able to see the content of your website. Any question? Okay, if you are not, you know, I know that you like to, you can add your own notes, but use that link and you can look at the definition on there. Okay. So we know that the header would contain information like about the web server. Okay. So today when you scan for recon, you're gonna see that it's gonna say Apache 2.x version, or you know, Nginx to, you know, so and so version. So that's considered the software for the server. So your server might be running Linux, right? Sometimes it can identify that, sometimes it doesn't. Sometimes it will say Unix, Linux, and then it will say Apache 2.0.1. But other times it can only find the software that's on top, which is the higher level application compared to the OS, even though we are scanning for OS. So in the header, it's going to contain some of that, right? A lot of the tools, it's using the header to be able to distinguish like what kind of system that is. And how can it find the operating system is, we're going to talk about fingerprinting, is when you are using TCP IP scanner, each operating system is responding differently. Did you know that? So a Mac OS compared to Linux and Windows are different. So this is what you're gonna see when you do that in the later part. So in your HTTP, in your HTTP communication, you have the HTTP header, your web server header. It also have a response body, which is where your data is gonna go. So if I'm working with things that are JSON or XML, a lot of the times you see this as like data sets. You're gonna see the data content in the response body. Now, most of the time when we're using, you know, secure website, your information or your data is transmitted in an encrypted manner. We know that, and it uses stream-based encryption where it does one bit at a time. However, right, in some of the attack mode, we can capture that session, impersonate, and be able to pull the data or redirect that data content somewhere and be able to decrypt it, right? I think in the previous chapter, we talked about the 2 steps in that, and we'll revisit it. So in your server response, there are 3 main parts, and I forgot to bold this. Your status line, which is including your status code, your headers, which contain response and the content type and length. So think of the headers are kind of like the cover page to your paper, right? Or the cover letter to your resume. It gives a little bit summary of what that response is supposed to be. Then in the body, that's going to be the actual raw data. So in the next part, it asks you, what type of information can be found for the web server response body? And that's easy. We say that the data for the client requests, such as JSON, XML, formatted data. Because in order to give you or serve you the data, what you would see is that data is not coming from the web server. A lot of the time that data is coming from a database or a storage system that has the data. Because if we put the data onto the web server, right, that would require a lot of processing, and that would, you know, well, even when you centralize a system like that, it's gonna cause a lot of problem in the long run. So in the design, what you have is the web server, its job is only serving you the web pages that you see from that site. And then on that, they're gonna link the data to the databases. And that could be like, you know, relational, non-relational, it all depends, or other content. So if you're looking at like the youtube.com, the way that Google has it, the videos are not actually coming from that web server, right? You know that it's coming from a database that contains all the media files. And so when you upload and download your YouTube video, it's from there. It's just linked to the DNS and the web server. So the purpose of the HTTP headers is that it provide additional instructions or metadata about the server response for the requested resources. So as a client, your system, when you type in your browser, right? Let's say youtube.com, the HTTP headers, its job is to contain the information that would be for that particular request from your system. Right, so when you're clicking on a video, that request goes back to the server and telling the server that you are requesting this video. That server is then gonna pull, it has instruction, the code to pull the content, that particular record from the database, and be able to send that back to you only because the HTTP header is there. Okay. So there's like a lot of like the background processes that we have to understand on how it's used. And so if you can visualize that, then in certain area, when you're troubleshooting or when you're looking at the security aspect of it, what can you do to solve that problem, right? That ultimately, that's what we do, is to solve the security problem. Any question? So here you can find the information, and then also on the bottom. So to just really expand on that, right here. And then if you have additional requests and information, so that it communicates, the headers is a way that the client can successfully, or how the client can be communicating with the server. And, you know, so I went through like 20 different sources trying to kind of scheme down on like what would be considered general, or, you know, like what I should tell you as far as request headers. So if you go to development websites and resources, they're going to tell you a bunch of stuff about all the additional things on headers. So if you click on that link, it's going to take you to more of like a development web-based stuff, right? But if you read like, you know, networking books and go to resources for that, it's a little bit different. So I've decided that I wanted to kind of, you know, use some of your book content, and then use some of the resources that I found that would be useful for your profession. So we already talked about a little bit about the request header, but it's really containing the information about what needs to be fetched when the client requests that resource. Okay, so basically it's a message to the server. Okay. It's like you're sending a message to the server from your system asking for a video, or, you know, maybe a picture. And then when the server responds, it's gonna respond with the response header. And that contains the information of what is provided, or what it is providing. So if it's serving you a web page, then it's containing in the response header. So when you scan today, you're going to see some of that, right? Like our index file is going to be part of the result. So you're going to see that in the response. But on the scanner, it's not going to tell you, oh, this is, some scanners are good at categorizing them, but a lot of the scanner is going to lump everything up into a section of output. It's going to say, oh, this is the software, this is the target, this is what it's serving, and this is the file. Sometimes it doesn't even give you the file, right? So how does it know? How does it know what kind of data that is being served? Well, some of that comes from here. The metadata of that file needs to go into the response header. And then you have the representation header. This is going to be the body of the resources. And this is gonna be how it's gonna encode and decode to show you your data. So you guys know UTF-8, like ASCII encoding. So that's how it's gonna take numbers and translate it to, letters and characters, and so that way you can see, or even images on screen, right? So, or moving images on screen. So all of that is really how going to be represented or present to you. And then for us, payload is important because attack often can be detected with payload. So the payload header, it is containing information about data and the content length. So when you look at the content length today, that's part of the payload header. And then also coming back to what kind of encoding that's used to transport, not to present, but to transport. So I can take the raw data and it's encoded into something, right? That's different than the representation of data, which is encoded in a different system. So that way the human can see what's presented, but the system needs some type of encoding system to transport it, to get it from point A to point B. So it doesn't necessarily is the same. So that's why you see that it is independent from the representation. Any question? Okay, and then there's this general headers. And I kind of agree and disagree with this, but this is where your date and your general, very simple information is gonna go, right? Things that don't really belong in the other categories is going to be classified as a general header. Now, depending on the source that you look at, in development area, there's no such thing, right? Like they have actual details in some of the headers. Headers are specific to technologies and things that are indicated. But, for just like knowledge base, I guess we can say that some of the simple information that didn't fit into the other header is gonna go there. Let me move number 4 down. So coming back to 4, so we know that, and you saw this in the notes, right? I took that from the notes, that the server is gonna pass information with a response. So whenever that your client is the system, sitting at the computer connecting to a site, right? That's a request message that's being sent, and then the response is going to come back, and that's a response header. So when we're using these tools, headers are what we actually see, right? And then some of the network monitoring tool, it uses packet header information, but within that you would see HTTP. So how can it distinguish? Well, everything has a label. Think of this as like a label for all the message and all the communication, right? Each time that it sends a message, there's a label that it says that, oh, this is an HTTP and this is a request. This is a request message. And then with that, the system would then be able to distinguish between whether it should respond to it or not. So the case sensitive with the case insensitive with the colon and the white space. This, we use a colon to indicate what? You guys know? In a URL, when you're looking at like a URL, the colon in a URL indicate port values, right? But in the header itself, it needs to represent a specific value that, so if you see this is coming back here. Give me a second. Let me pull back the notes. Okay. I had added for you guys to see. Yeah, so in the header, when you look at it, it's all lowercase, basically. A lot of it, except for some of the names for the OSs or whatnot. And then you would see the colon and then some kind of value. Okay. Those value can represent certain things in certain field. It really depends on what type of headers that you're looking at. So if I'm looking at payload headers, that's gonna be like a lot of it is gonna be size for the data or the type of encoding that I'm using for the data. So it's kind of generalized when we put that down. But when you look at it today, I tried to look at like how it would be formatted or presented to you in a certain way. All right. We touch on question 5 as well, request header. So it contains the information about what's fetched, right? That's the process of request is to fetch. The response header is what's provided by the server. So the request is the client fetching. The response header is going to be what the server is providing. The representation header is going to contain the body of the resource, things like MIME, which used for mail, and encoding, or even compression. So when we're dealing with, different type of system, because mail is also web-based, right? What you would see is we have to have ways to represent that back to its original state based on what kind of information is being requested. And then we talked about payload. That will be your content length and encoding for transport. And then the general, these are, it could contain date or time or anything that doesn't belong to the other categories. Any question? Now, you don't have to use an actual software tool in an operating system to scan, or you can use web-based. They have web-based scanner or tool that you can find information on your HTTP header. There are lots of different tools out there that, if you research it, you will find it. Some is like Windows-based, some is Linux-based, and then you have web-based. So what we can do is we can visit this, right? It is an API. So API stands for Application Programming Interface. It is usually a program on top of a program. So it's not a regular program where it would have entirety. So it's usually working with things like browser or another application, but it's not really like a plugin. So it's a program talking to another program, so that way you can use it for different purposes, like to be able to obtain information or to be able to have an automated process, things like that, right? So hold down Control and click the link. So what you see here is your headers, right? So it tells me that that's the type HTTP 1.1. So I know that it is HTTP header. Earlier, we talked about status code, right? 302, and it says found. But as you go down, you're going to see various sections. So it's basically, we're witnessing a conversation between system to system, right? This is kind of like the text message that it sends to each other. Think of it that way. Okay. And then you would have char set UTF-8. So you will have the content type, text, HTML, the encoding, and then some integration with security policy. There's permission and it says unload. That means it doesn't have, and so on. Right? We know that some website would also have cookies. Most of them do now because they want to gather the data, your data. So you would see that they would have some cookie information there, along with like, if they enable cross-site scripting type of injection and so on. So all of that can be also built in, but you would see. So from an attacker perspective, right? A lot of times they look around at these things, right? They would look at the web server, whichever is the target, examine that web server and the communication across between that server and the clients. So there you go. Right. So as you look at that, you're going to answer the question. And you can include like the 302, the 200. So if you go down to right here, right, you would see that it is 200. And then we have the date and the timestamp. So I think the security side of it, you would see that there are rules sometimes can be integrated. There are websites that you can't really scan them or find information about them because they apply some of the rules. Okay, so a lot of the integration you see with the policy to prevent additional things. But then, some of them don't have it. Why? Because, implementing those things might cripple some of the other areas or the functionality of the site. So they have to consider that as well. But then they have other measures in there to protect it. So as you look at it, is there cache control? Is it private? Usually it is, right? Cache is a temporary storage location. And what they can do is they can reserve a certain amount, but you don't want too much of that because that's storage. And then your content length, you can use the top or the bottom. That's up to you. So how can I find my server information? Right here, it would tell you, right? What's GWS stands for? Google Web Server, perhaps?
So just as a question, we are saving both request and response, right?
Yes. And then you see that the port, so sometimes you see that in the field. Let me kind of zoom in. I know it's tiny, and if you're looking at the same thing, you can see. But yeah, so you see that 443. 443, that's HTTPS. All of the stuff that we're using now is usually just all HTTPS. There's next to none HTTP mostly for us anymore. Other part of the world, maybe they still have that. And then in the case where if there's compression, remember we saw that earlier. And then cache control right here. A lot of the times you see that it's private. And they have set cookies here, right? For how long the cookies expired. Now on the forensic side, we look at the headers for the web, and then we would know like what was stored and what's not for that particular activity. So for example, like if you're looking at someone accessing a certain website because they committed murder or whatnot, and they had looked up all the resources for that particular crime, you would look at this information and then sometime you would be able to find things in different area of the system because it's stored temporary, like, browser-based stuff stored. So perhaps you can find some of that there. But headers are definitely important in our world for sure. And then cross-site scripting protection. Depending on the actual page that you're looking at, right? In the case if you go to like Gmail section, that might be a little bit different because when there are form-based or set, right, or put tasks for the server, that means that like people entering data and store, that's a little different. Okay. So HTTP headers is gonna be displayed on a banner, right? Don't think of like a website banner, what you see at the top of the page. No, right? The system banner or your server banners contain system information. What's being used, a lot of the time, software that's being used. And in security, that's important because the version of the software speaks to the vulnerability. So if you're using Apache 1 compared to Apache 2, or, certain type of version would have a certain vulnerability. So having that information is going to be useful to see, what area we can reduce in vulnerability. From the other perspective, what area we can capitalize on to perform attacks or to cripple certain systems so that way we can bypass certain service and so on. So banner grabbing is a technique that we would be able to obtain information, especially software information, so that way we can identify the vulnerability. From a defensive perspective, we would be able to fix or reduce that vulnerability or remediate it. Whereas from an attacker perspective, we would utilize that vulnerability for other, not malicious intention, but maybe override a service, stop a system, and so on.
I have a question.
Sure.
Where would you find the information for number 7?
It's
notes?
all on the notes. That's correct. And I can point you to the page. So if you go down, and it talks about like after end-to-end headers, it goes into FTP banners, and it doesn't have to be FTP banners. It could be HTTP, SSH. And I wanted to put down the information. I'll come back to this for FTP. So there you go. Banner grabbing attack. That's on page 4. So a little coming back to the web, HTTP headers, you can use JavaScript or Python to pull the data, right? And a lot of these security tools are written in Python, so that way you can like output it into a file. We can organize it into a CSV and do something with it, analyze it, go through and filter it and so on. So FTP, that's for file transfer protocol. There are FTP servers, but now we would use secure FTP servers. But the process for FTP, usually you would see the banner first. So when the client is connecting to an FTP server, right, the banner's job is to update the client with information, right? And so now, but in order, so it provides the client with the information. So establish connection, it's going to display the login banner. So if I'm using FTP and I allow anonymous, you're going to see that today, right? it's gonna prompt the user FTP login, and then they can log in with anonymous. There's no password, so they can go in. But with the regular user, you can add them to the group and be able to set that up. And then you would have authenticated user. And then after that, it's gonna display another part of the banner, which is gonna be, you know, allowing them to access the FTP folders for upload and download, read or write.
Can I ask you a question?
Sure.
Enter, pen testing is, what was it mean?
So pen testing is, we would use techniques to be able to look at systems, weak areas. So that way we would be able to examine how we can secure the system or improve security technologies for that system. Yeah. Okay, so some of the tool we're gonna be experiencing, Nmap is gonna be your best friend, right? I say that about all the tools that we use regularly. So Nmap is a very useful tool. You know that it is an active scanner. It talks to the system, it pings the system, and so you're not gonna be stealth, right? Netcat, it depends. But Netcat, it's a listener. So you would see, and it's been around for a long time. We've seen Nictel. You probably have seen curl before or CURL. This is often used to get information as well. And this is also used to download things too. So, and then wget, this is also used to download. So if you don't use, you know, Git, you can also use curl and wget to download and install your packages from the web. So you might have seen those before. So in a banner grabbing attack, depending on the type of protocol, so you must, I'm going to say this again, in security, you must know your ports, okay? No one's going to help you. And, you know, you might have a cheat sheet. Sure, you can look up your phone, whatever. But when you do incidents response, sometimes you're going to see a lot of information. You must know your port. Which port is mapped to which protocol, and how that's going to be not secure. So when we say FTP, we already know it's not secure, right? SFTP, that's different. It also uses port 22, which is SSH. So going back and learning networking and the ports and going back to 27, very important to review those things, okay? It's not because we want you to memorize them, but it's going to be useful when you read for analysis, when you read this information. So we talked about active, passive. A lot of the times it doesn't directly work with that system. Same definition as what you've seen with attacks and other things. So the banner grabbing, it doesn't communicate directly with a certain type of system to obtain the data. Things that, you know, it might listen in the back compared to that it would go out and query that actual system. So we'll see. On some of these tools, you're going to go along and you're going to take a look at those. Okay. So, we talked about banner grabbing. For number 8, how can you obtain FTP server operating system version? What tool should you use? You would grab the FTP server banner. Some of the common tools that you use is Netcat and Nmap. Nictel, yes and no. I think Nictel is very common for web server application, but yeah, you can use some of these tools. Curl, Telnet, and wget. If the FTP is linked to the web server as well. Sometimes you would see a system that holds multiple roles, because in order to make it publicly available, they usually make it also a web server, so you can use some of the tools for both roles. Okay, I kind of lump them in there. I kind of don't want to, because sometimes that can confuse people. But you would start out with Telnet to see if you can direct connect, and most security people know they disable Telnet because Telnet is not secure, and it's also a way to, as we see today, to grab banner, right, or do other things. But yeah, you want to turn Telnet off. You guys know the port for Telnet? For those of you who passed, what's the port number? Is it 21? 23. 21 is FTP, 22 is SSH, 23 is Telnet. So SSH is different than Telnet because it's more secure. It uses encryption or keys with authentication and communication. It allows you to directly or remotely connect to a certain system in a secured session. So for example, I can use SSH to directly connect my system to your system. In the past, we would use Telnet to connect the computer to another system. A common thing that you see in IT is we use SSH or Telnet for things like configuring routers and switches, security appliances. You have to find a way for two systems to communicate directly. And we would use something like, a program that have these capability, but you can use command line, enable that service, and then communicate, right? For the SSH banner contains also the server identity, the version of SSH. Most of the server that uses open source, they would use Open SSH. Even some of the proprietary product I've seen that uses Open SSH. And Kali Linux comes equipped with it. Most Linux Debian releases have Open SSH. So you can make your system an SSH server or a client. So you simply just manage the configuration and allow the service if you want to enable that, right? We'll see some of that today. And on the banner, you also see updates to the services. So the version of SSH is important. It plays a role in encryption and fraud for that technology because, as you know, a lot of the protocols and the technology, they've been around since the 70s, right? You know, 30, 40 years in, and we're still using them. We have improved them over time, but it's not necessarily going away. But SSH banner also contain warning and notification. So they use a lot of stuff to kind of deter, right? Based on security, for security purposes, or implement policy or notify the user of the policy. So after the FTP section, you will find the SSH banner section. And so this is important to highlight. You need to interpret the SSH banner to understand its configuration. Today, I'm giving you two views. One is you configuring the server, and then when you scan, do you see the information you configure? You'd be surprised, right? Sometimes it depends on the tool you use. You might not see everything that you actually configure, like anonymous login, or that specific version of SSH, or the OS that it's running the SSH on. So so you have the background view, and then you also have the from the external view where you're running the scan and you might not see everything, right? So some tools are better than others. So a lot of times we use this for security reasons. I mentioned that already, for deterrence purposes, to inform, systems or users of the policy and how it's enforced. And the roles in, if you are you're a system admin, if you're a network admin, you're a network professionals, you're security people, you must understand SSH, right? Even in development. Because a lot of things remotely connected, and you need to be able to understand the process. So, all right, any question? Then we'll get to the last part. I'll give you a little break. A little shorter in the chapters today. let's bring it here. Okay, for 10. So how can SSH be useful in enhancing server security? It can be configured to display warning messages, disclaimers. Server administrators can inform clients about consequences or of unauthorized access, or monitor their actions. It can act as deterrents to unauthorized users. It can also be used to inform clients of the server policies. Basically, those are rules of the server, the requirements, such as enforcing strong passwords or disabling a certain type of features. So we can use SSH banner for warning or applying security policies, right? So after today, I hope that, with some practice, and a lot of these tools, like the commands are so easy, but you need to look at their documentation and practice other commands and other options just to make yourself a little bit more knowledgeable in the tool. You can include things like you're knowledgeable in banner grabbing for FTP, SSH, HTTP servers, right? Using curl, netcat, nicto, nmap. I tried to find Xprobe too, and they took down their Git. So hopefully that will come back up for OS fingerprinting. And then I'm gonna try to find ways to get around some of the additional feature for burp, and we'll try it. Any question? They used to enable more feature when you use their temporary version or the community version, but I've noticed that lately, like, they took away a lot of the features on there for burp. And, with this class, my intention is, a lot of the things already exist in Kali. That's why I'm using Kali continuously. So you don't have to install and then make your own virtual machine, right? Just pull it down and be able to use it. But hopefully, if Kali interests you, they have a certification for offensive security. They have multiple actually, but you can get the intro level certification. And if you plan to be a pen tester, an ethical hacker, that's a good certification to get outside of Pen Test Plus or certified ethical hacking. Okay. If you want to do red team and purple team, that's the one to get for offensive security. If you get that on your belt, it will look good after that. It's not too expensive. I did look into it, but okay. Last part is the operating system fingerprinting. We've done a little bit of this last week and the week before, right? You've seen Nmap being used, and you saw the option that we were able to pull the operating system from the scan that we perform. So when you are fingerprinting, you are directly working with the system, right? The first week we talk about footprinting, right? And footprinting can be a little bit more broad, where we are looking at information about that target, but not directly at that target yet, right? So if I need to find the OS of your computer, right, I'm fingerprinting that system. But if I'm footprinting your computer, I'm just gathering information from the outside of it instead of directly working with it, even for active or passive, right? So I might ask people about your system. I might ask you about your system. So that's footprinting. Okay. So in OS fingerprinting, very similar to all the other passive and active technique that we talked about. The passive, it involves just observing network traffic and analyzing characteristics of packets to determine the OS. Because as I mentioned before, based on TCP/IP suite, each operating system responds to traffic differently. And this is how they can distinguish one OS from the next, Unix from Mac from Windows. Is it 100% accurate? Not really, right? Sometimes you do get a tool, it's gonna tell you unknown operating system, or it might say that it would guess it wrong, Windows XP or something weird, right? But that's okay. We would try to validate it with using other tools. And some tools are passive and some tools are active. So active fingerprinting is when you send traffic specifically to probe that particular target, and Nmap does that, right? If you're doing HPing, that's directly pinging that system. If you're sending, like, most of the time they ping, but if you're sending certain requests directly to that system so that way it can give you the response header, that's an active fingerprinting, right? Some tool would, send the target. For example, I'm doing banner grabbing for a web server. It would send to the web server to get the response header, and that's how it's able to tell you what kind of OS it is, what kind of software it has, what kind of content type and content length, and so on, right? For the remote fingerprinting, it uses remote tool or services to gather information from the target OS. I might use a web-based tool, right? To be able to gather information. And we just did some of that. Okay. We use a web system to obtain another web system information, like google.com. So when is remote OS fingerprinting used? It's in the name, right? If you can't physically or directly access it, then you would use it. Or sometimes if you have to fingerprint a large scale operation like many systems, that would probably be useful. But there are tools that you can do batch job too, so and automate it. So the 4 elements to determine the OS. So how can the traffic really represent what OS is receiving that traffic, or which OS is receiving the traffic? It's based on the time to live. So TTL stands for time to live. And each operating system type would have a different set of TTL values for outbound packets that are leaving. Also, the window size is different for each of the operating systems, so that value is distinguishable. And they also have another value called the DF, or don't fragment bit. That's also gonna be distinguishable. And then TOS is type of service. And because operating system are really designed as a software to manage the resource ultimately hardware, right? So the type of service that it can be integrated are distinguishable. And you see that between Windows and Mac and Unix. There are services that they all can do universally, right? They, like SSH and different things. But things like there are web services, for example, if we just take one example, like web server on the Windows side, it's IIS. And on the Linux side, it's Apache or Nginx or whatever, right? So there are different type of tools and software that are specific. So, and it speaks to the service that are enabled for that OS. And the design and integration for the services are different. So for false positive and false negatives, and for me, I think this definition is kind of lumped in together because they're kind of close, right? So the false positive in OS fingerprinting is if you get incorrectly identify the OS. It does identify the OS though, but it's not exact, which lead to the wrong assumption and waste time. For example, I am scanning or I'm fingerprinting a server and it comes up like a wrong version of Windows. It does provide me with Windows. And it might say, server Windows 2012, where it should be saying 2019 because the 2019 has number one, different features. Number two, it has, maybe enhanced security compared to 2012 or some earlier version, right? So that can be misleading. The false negative, it does not contain valid information or no information at all, right? Leaving the system vulnerable to attacks. So likely on the false negative side, it contains very little information or no information at all, or completely incorrect information. So if I'm running, let's say, a Linux server and it's coming up unknown, right? That's a false negative. You're going to see that today too. So when you write up your report, you need to make sure that you take a look at those things, right? We can't disregard because, unknown, we have to run other tools until we find that information because that is essential. Software is a big flaw for the system, so we wanted to make sure that it's up to date or fix some of the issue. Any question? I think can I move down? Or are you still working on? You're okay. So a little bit more. Okay, so I'll put 14 to the next page so in case you're still recording the answer. So for 15, it says, what technique is used in operating system fingerprinting to identify specific operating system running on the computer or on the network device by examining the unique characteristic of TCP/IP stack? It's already in the question, right? This is called the TCP/IP stack fingerprinting, and simply that is just network scan. Right, it's looking at how the system is communicating with using TCP traffic. compared to UDP traffic and so on. So in the case of some of the tools that you see in this part, you know, sometime if you show verbose, you might be able to see more, but it would have like the scripts that's built in and it would generate those scripts. So it would perform the TCP IP stack fingerprinting attack. And that's how it can tell you exactly what the OS is. Because like I said, right, each OS respond to traffic differently. Based on those 4 factors that we just looked at earlier. Just like all the other techniques, you have active and passive. So the active fingerprinting, it sends packets to the target and analyze how the target responds. So it just generate traffic and sends it to whichever IP or URL that you have it set. The passive fingerprinting, it looks at the network traffic simply just based on monitoring, like sniffing. It's just looking at the behavior and how the systems are interacting on that particular network, and that's how it's able to distinguish. So active fingerprinting, know that it is noisy, but it is a lot more accurate. So you have to determine the type of tools that you're going to use next in the next phase. That's what we're approaching after this week. We have to determine, and a lot of it, the factor is going to come down to resource, right? And then if you know, how detectable are you? Okay. So active fingerprinting or active tools are always going to give you more accurate answer or results. And sometimes you don't have a lot of time to do that, right? Sometimes you only have a certain time window, or sometimes, you know, you have to bypass an intrusion detection system in order to generate the traffic. Or you might get blocked by a firewall, so you have to find your way around that, set up a proxy, and then get that proxy to mask an IP and so on. So we'll talk about that more. And I intended to do like maybe we'll set up like a wireless network, and then we'll see if you can get into a wireless. You can set up like virtual machine servers at home, right? If you have an old router, connect it with the virtual machine, let it talk, and then see if you can get through that wireless router, like you can brute force. I have Wi-Fi Pineapple too, so once we get through the wireless, we'll do a replay. So I'll show you how you can use embedded Linux. If you love Kali, everything else is easy. You can do a replay attack, or you can do an evil twin attack. There's a lot of things that we can do. And it's fun. And then I have like other little gadgets. I show you guys Hack 5 already. So you can probably find comparable products or create your own. So I teach this class a little differently than, you know, so yeah, you're gonna use scanners and things if you're using cloud-based lab. But I really think that like cloud-based lab, sometimes it's too control and it's too perfect. You have to consider variables when you're doing this type of things. Like, you know, even version of software change, you see that, right? Like Kali, it works one day, it doesn't work with the tool the next, they remove the tool. So open source is always evolving, and we have to evolve with it as a professional, right? So this is why like security field is always changing and technology is always changing. And then yeah, maybe if we have time, we'll do some IoT stuff when we get close to the end. but I do want you guys to also prep for your pen test plus. So I heard this morning that they processed the PO finally. So I'll be able to get you your test out access soon for pen test plus. I don't have that. I might have some. Let me see if I have enough. And then I will have test out vouchers. So I mean CompTIA vouchers for pen test plus, because they just cut the check for that. So hopefully I'll get it by next week. I'll let you know. So if you want to sit for this exam after this class, right? Study and then let me know. I'll give you the voucher. Okay. Any question? Only 16 questions today. And then I'll let you take a break. Download Cali if you haven't. They just released the 2024.1, so it's slightly, it looks a little different, but most of the tools are the same. So let me stop recording right now.